was used to find out. This was the purpose of the Rutherford experiment, to find out the structure of atoms, and he found the structure to be this description that I just gave now. So now let's go to the next one, the Chadwick experiment. So from what we have here, I said Chadwick discovered.
Hello.
Yeah, hello.
I sent a question on the chat.
I don't know. Could you read out the question, because going to the chat would alter this slide. I don't know
If electrons are attracted to protons, why can't they be together in the nucleus?
Okay, that's a very, very good question. There is this stuff that they call at the center of the nucleus, we have positive and negative. We have positive protons and the neutron. So there is this pull there's a force that is at the center of the atom that is pulling just the positive atoms. So this force at the center of the atom, that's from the nucleus of it, is what actually is pulling this. There's this space. I said there's a space that allows the electrons not come into the nucleus. There's like a space where this nucleus cannot. The electrons move around the nucleus, and they cannot. Their distance cannot change. Just like as if, let me use the planets. I believe we've seen that analogy well. That the planet, the sun is just like the nucleus. Then electrons, they would want to come to the center, but now they cannot leave their orbit, the circle around the nucleus that they are moving around. So there is the repulsive force from the center of the atom. There's an attractive force from the center of the atom that is pulling in the positive protons. So these protons would want to go and meet the electrons, but because of the pull from the center, there's this pull from the center that is holding in these electrons at that center. It will now restrict the protons from going to the electrons, and the space that is between the nucleus, the nuclear cloud would prevent the electrons from coming into the nucleus. So it's only the protons that can be drawn into the nucleus, but the electrons cannot be drawn into. So because of this, the protons is attracting the nucleus, the electrons, but like I said, there is a glue holding the protons at the center. These protons are positively charged. Normally, positive is supposed to attract negative. So there's like a glue holding the positive at the center. So now this glue is holding the positive at the center. And now there's a cloud, a space that is preventing this negative species to enter into the nucleus. So this is the reason why they move just round. They just continuously move around, trying to find a way to enter the nucleus. They just keep on orbiting around the nucleus. They cannot leave their orbit because there's a pull that is always pulling them into that center. So no matter how much, the only thing that they can just do is they can only come to the surface of the orbit, keep on moving, depending on their attraction towards the center. They'll keep on moving in that orbit, different orbits, as many electrons are around, and different electrons that are different forces that are pulling the electrons, the different quantum values of this electron and their position in the event of these SPDF orbitals. So depending on the position that these electrons are found, there's always a force that is pulling them at different levels. There's always a force that is pulling them at different levels. So there's a cloud that resists each of them. Just like, I don't know the physical example I would give now. We know the temple now, the temple in the olden days, like the Bible, they said there is the holiest of holies, where normal people cannot come inside. It's just that kind of analogy. There is this zone around the nucleus, this cloud around the nucleus, where the negative species, even if they want to come in, they can't come in. It's only positive electrons that are being drawn into that center. And these positive electrons, even if they want to go out, they cannot go out because of the force that is pulling them inside. So it's just like I said, there is a ball surrounding every positive particle inside. So then their negative family outside can just hang around, be waiting for when one day they will come out and they will see themselves. So that's just how it is happening. It's not really that the negative species don't want to get attracted to the positive species. The reason why they prove that they want to get attracted is because they keep on staying around, but they cannot come in because of the obstruction that has happened.
Hello?
I don't know whether I'm giving a example of the explanation.
Hello?
Yeah, I can hear you. Yeah, I can hear you.
So that means the force of attraction between the proton and the nucleus is stronger than the force of attraction between the proton and the electron.
Exactly. 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 So the proton and electron now, different electrons. Now, if you, I don't know, you sound like someone that's actually grounded in chemistry. Different electrons now, they have different electron energy. So due to the level of energy or the level of attraction for this, due to their affinity for the center, for the protons, will now determine their zones, their different orbitals. So there's always a pull between positive and negative. But now, when this pull between positive and negative, the one at the center is stronger than that, holding the positive inside. Just like there's a force, maybe there's a wind that is holding the protons inside the center. The electrons want to enter, but they cannot enter. Bouncers are at the door. So no matter how much they want to enter, the bouncers will restrict them from entering into this place. And no matter how these protons want to go outside, the winch is holding them from going outside. So that's just actually what is happening around the electrons. So that's just the explanation of how the nucleus, how the structure of atoms are, and why they move in the. I don't know whether it's clearer now. Hello.
It's clear, sir.
Hello.
Thank you. It's clear, sir.
Okay. Okay. So now the next experiment we're trying to talk about is the Chadwick and neutron experiment. So this James Chadwick, his experiment was the experiment that discovered the neutron, and he named it. Most people have been discovering other things, but they've not really been giving them specific names. So that is why it seems like as if they will say one person discovered something, another person discovered that same thing, and but one person discovered something existing with other things, but the other person is one that will give it name. So this James Chadwick was a student of Rutherford. You know, we said Rutherford was one that observed the real structure of atoms. So James Chadwick, he was a student of Rutherford. He was a student of Rutherford. So as Rutherford studied and found the structure, Chadwick then went further to discover that there is actually a species that is called the neutron, and that neutron is also at the center. Because Chadwick and Rutherford's experiment, after he was doing his experiment, he focused only on getting the structure, and he was able to get the structure. Then this guy, James Chadwick, was then able to find out or isolate that there's a particle that is called a neutron. So at that time, the only thing that they knew of was just proton and neutron, and proton and electron. They did not know anything about neutron. Well, now this guy, this James Chadwick, when he carried out his own experiment, he found out that there is an extra particle at that center, and that particle does not have any charge. It is neutral. And this particle, he said he discovered that these particles they had had they mentioned that. So he said these charged particles they are neutral, and they also exist at the center of the element, and these particles are responsible for the weight of the nucleus. So he was the one that found out that it's not only protons that are at the center, that there is also another particle at the center, but that particle's charge is neutral. Because that particle, he said that this particle cannot be negatively charged, because if they were negatively charged, why are electrons now outside? And if they were positively charged, why is it that there are specific numbers of positive charge of electrons, but there are still some other particles that are inside that we don't know their charges? So then he carried out his own experiment, and he was able to find out that there were some other particles neutrally charged, that they don't react to electric field, they don't react to magnetic field, but they exist. I don't know whether you are following what I'm talking about, what I'm saying. He found out that in his own experiment, he found out that these particles they did not have attraction for electricity, neither did they have attraction for magnetic field.
Magnetic field.
Yeah, they don't have attraction for magnetic field, they don't have attraction for electric field. So these particles, and they are also still found in the center of the nucleus. So he then assumed and gave the name of these particles neutrons, saying that these neutrons they have no electric charge and they are responsible for the mass of the atom's nucleus generally, or they are the major things that are responsible for the mass of an atom. Them and protons, they are responsible for the mass of every atom. So not electrons, just to get the mass of an atom is a combination of the weight of the nucleus. And this nucleus, they found out that the nucleus is made up of two species, positive and neutral. The positive is proton, the neutral is neutron. So neutrons have protons have their weight. So when you combine the weight of proton and neutron, you get the weight of the nucleus. And this weight of the nucleus is what they call the weight of every element or every atom. because electrons, they just float around. They don't really stay in one place. So you cannot, their weight is insignificant because they are also very tiny. So this guy, Chadwick, he was one that carried out further experiment on Rutherford's experiment that he was carrying out, and he discovered that there are particles at the center also. And these particles at the center, they have neutral charges. So I don't know if you guys understand what I'm, or you hear what I'm saying, how what this guy's talk was about. I don't know if you guys understood what I just explained now. Hello, can you guys hear me?
Yes, I can hear you.
Yes.
Yes, sir.
Okay. Okay.
Yes, sir. I have a question there, sir.
Okay.
I
Yeah.
thought from the previous one you thought of that neutron is negatively charged, but Chadwick
No,
is saying that
neutrons,
it has no
neutrons are
charge.
not negative. No,
Sir?
if I said, if I said neutrons are negatively charged, it was probably a mistake of word because everywhere electrons are negatively charged. Neutrons are neutral. And I remember saying that neutrons, they are neutral electrons or neutral protons. So neutrons are they don't have any charge at all. So
Okay, let
sit
me
back.
correct you.
So probably it was maybe a mistake from my sentence. Maybe as I was, because this tron, sometimes I can interchange electron, proton, sorry, electron, proton, neutron. So this whole thing, sometimes if I had mistakenly said neutrons are negatively charged, pardon me, the real thing is here. Neutrons, their charge is always zero everywhere. They always have a zero charge. Protons, their charge is always positive. Okay, I think I should use my illustrator. I just remember that I even have an illustrator. So this is how it is. Let me say we have, oh God, let me see whether I can be a little too big. Let me draw something. I'll use color. So we have blue. I'm using blue to represent protons. And this is the nucleus of an atom. So I'll use yellow to circle as the nucleus of an atom. So yellow is representing the nucleus. That is that cloud I said that is protecting electrons from entering inside. So blue is representing proton. Then I'll use red to represent neutron. Red represents neutron. So red is also inside the nucleus. So now around this stuff, around this nucleus now, we then have what they call the electrons. These electrons, their own work is to be moving around. Moving around this thing. They cannot enter, they'll just be moving around this cycle. Moving around, keep on moving around. So this is how the what they call it, the structure of an atom, according to Rutherford, was. He said at the center we have protons and neutrons. So I said protons, I'll use blue for proton. So protons are blue. Sorry. Protons are protons are the blue ones. Neutrons are the red ones. Oh, sorry. Neutrons are the red ones. Then electrons are the black ones. So now at the center now, you can see that at the center is only two colors that are at the center, the red and the blue. And the two that are at the center are positive and neutral. So that's why sometimes you hear that they say the nucleus is positively charged. The nucleus of every atom is positively charged because the only thing that is charged in the nucleus is the proton, and the charge of that proton is positive. So that's why they say the nucleus is always positively charged. So, but in the nucleus, there are two people that are inside. One of them does not usually brag. Why one of them usually brag? The one that usually brag is proton. He says it's positively charged. Why the one that does not usually brag? He does not say it's charged. He says he does not have any charge at all. So while electron moves around this inner tent. So I don't know whether this is graphical enough. I forgot I even have this illustrator. I would have used it to explain the cathode ray listen. But let me see whether I can go back to that point and possibly try to explain it. Sorry. so that I can erase this. Okay. So this is the cathode ray experiment. Sorry, this is the cathode, how the cathode ray experiment, the cathode ray tube look like. It's like this. We have two pipes. And on this pipe, there is this opening here. Oh, there is this opening here. Then at the ends of this pipe, they closed it and they put wire. At the other end, so they closed it, they put wire. So the wire on one end is positively charged, while the wire on the other end is negatively charged. So then they now notice that as they sucked off air from this tube, they took off air from this tube and they plug electricity to this wire. They put electricity to this wire. They put electricity to this. They connected this wire together to a battery. The positive side, they started noticing that some particles inside started moving towards this thing, started moving towards the direction of this tube. And this thing caused light. Particles drifted towards the positive side. So because of these particles that they were drifting towards the side, they found out that these particles that are existing, even when we've sucked off all matter, these particles are smaller than the atoms. And these particles, they are negatively charged. So these particles can be called electrons because they are negatively charged. They have to allow electricity. So I guess this is a diagram trying to show the cathode ray tube. This now you will see it in most textbooks. This is just the simple explanation of what it looks like. I don't know whether this is, at least it can help to cover up for the ambiguity that was happening before, that we're just speaking virtually.
Yeah.
Hello. Hello.
Hello.
Yes, I don't, sir.
Okay.
This is better.
So let's head on. Let's move forward. Let's move forward. So we were at, I don't know whether I should still go on to explain this millicants oil droplet, so that I can use this same illustrator to illustrate it. So this is what this experiment looks like. We had two flat plates. Then they started allowing oil drops to drop between it. Oil droplets. From one side, negative. Hello? Can you guys hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
sorry. So then
Yes,
as
sir.
these droplets were passing in between, they were adjusting the temperature. Sorry, not the temperature, they were adjusting the electricity. Then it got to a point where, as we were adjusting the electricity, these particles were not falling again. These oil drops were no longer falling. They then stayed on the air. They stayed in between these things. They did not fall, they just stayed on the air. And because of they stayed on the air like this, they believe that since the particles stayed on the air, that means there is positive and negative inside this particle. And some are going towards direction, while some are going towards this direction. There's a pull to the left and to the right. And because this pull is pulling them to the left and right, that is the reason why they did not fall any further. And since this kind of thing happens, it means that matters are made up of not just negative particles. Because assuming this oil drop was just going towards the right alone, or going towards positive, they will say all matters are negatively charged. But now,
And negatively
the thing did not go to the right. What did you say? Sorry.
I said that would have meant all matters are negatively charged if everything was going towards the right.
Yeah, assuming they moved towards just the positive direction, they would have assumed, they'll say, oh, it seems like as if matters, they don't have positive charge. All matters are negatively charged. So that's why they are attracted to positive side. But now, they did not just move to only the positive side. They did not also move to the negative side alone. So they were staying at the center. They started floating. The oil drops started floating. So this was now a proof that, oh, we know that there is negative species existing, electrons. So now, this experiment is proving that now it's not just negative that exists, there is also positive that is existing. And that is the reason why this thing can float on the air. And the charge of these electrons now is equal to the charge that we are seeing, because this is the charge that is able to sustain this electron, the minimum charge that is able to sustain this electron on the air at this point. So I guess they started from the lowest, started coming upwards till they were able to get a charge that could sustain these particles. So this was how the Millikan oil drop experiment happened. So I believe it should be, I've explained this a little bit.
Yeah, thank you, sir.
Then gold foil experiment, I don't really have an idea of how it looks pictographically, though. But the main takeaway from his experiment was that it was actually what was used to find the structure it was also used to find the structure of atoms, and it was also used to find that atoms, the protons are at the center, electrons are moving around, there's a huge space between them. Then it was Rutherford that found out this diagram I tried drawing before, that we had protons at the center, and we had neutrons also at the center. We had neutrons also at the center. Then we then had a cloud or a huge space that is preventing the other ones from coming in. Then the electrons then stayed outside the church. The electrons stayed outside this store. The electrons, their own work was just to move around. They could not come in. It was Rutherford that discovered this structure of electrons. So this was what Rutherford found out, that there is a center where positive species stay. And there's a force that is holding these positive species at the center. And there is also a cloud shielding them, a huge space shielding these positive species that is making them not get attracted to the negative species. And that's how they are. So this is the structure that Rutherford discovered. Moving on to the next one, we were at the Chadwick's experiment, where he found out that there is also a species at the center, and that species is known as the neutron. And this species at the center is known as the neutron. So that's actually for the Chadwick experiment. So then Planck's quantum theory. My time is even up. I don't know how much we still have left. Electric effects, quantization of energy. Oh God. Okay, let's see what we can do. I'll just try to brush off this Planck's theory, what it is about. So Planck's theory was actually a theory that was trying to quantify energy. Planck's theory is a theory that was trying to quantify energy. That is trying to say that energy, we know that people assume that energy is like a wave, like light. We believe that light, there is light wave. Light just has wave, or energy. Any form of, most form of energy is like wave. But this Planck theory was a theory that tried to say that energy does not just exist as wave. They exist as small particles at the same time. That energy, they have both wave properties and also particle properties. Though he's not really the one that stated it clearly, but his theory was one that actually brought about the idea of the fact that possibly energy could exist as not just waves, but they could exist as particles also. So this Planck's theory was a theory that tried to quantify energy, saying that energy does not just exist as wave, they exist as particles that have specific value. And this is in this theory, he said that the quantity for every single energy can be calculated using the formula HF. That is where H is representing a constant that he called the Planck's constant, multiplied by the frequency of that energy, because they believe that energy before they believed that energy was just like a wave. Like in light energy, we have light energy, we have thermal energy, we have electrical energy, we have different types of energy. They believe that it was just waves. They're just waves and waves have frequencies, waves have wavelengths, wave have all those kind of properties of wave. That's what they believe. But Planck, he then proposed that there is a possibility for energy to not just exist as wave. That is, even this light we are seeing is not just light wave. That light can also exist as particles. That this light wave, it's small particle that we cannot see. Small particle we cannot see. But these particles, each of these particles is the energy. They have a unique energy everywhere. Each of the particles have a unique energy that is now summing up to become the total energy that we know. And he said to calculate this energy, you need to know the frequency of that energy. You need to know the frequency of that energy, behavior in any energy that they knew before. That was frequency. You need to know that frequency and multiply it by a constant that he called the Planck's constant. And that Planck's constant has a value of 6.627, I guess, was approximately 6.63 times 10 to the power of minus 34. Okay, 6.626 was the former, was the like the longer version or the on estimated version of it when they've not rounded it off. That was the value. They said the value was 6.626 times 10 to the power of minus 34. So that was this Planck's theory was about. His theory was trying to suggest that energy does not just exist as just energy, that there's a possibility that energy could exist as individual packets, like single particles. Just like as if he was trying to, let me use a physical something that we could probably relate with. He was trying to say that energy is not just like water that flows like in a stream. That energy can exist as droplets of water. That this water particle can be broken down into small droplets. So that was what he was trying to propose. And this was the theory that he called the Planck's quantum theory. Trying to propose that energies exist as units known as quanta or packets. And this, his theory, was what was helped in in other levels of quantum physics, quantum chemistry, and so on. This is idea leading to several other experiments. Other scientists started saying this thing could be possible. They started carrying out experiments. As they carried out the experiments, they started finding out the findings because they assumed that energy was not existing as just waves, but could exist as particles. So this was one of the particles that I guess led to wave particle duality theory or principle. So let's move on to the second to the last slide, which is talking about photoelectric effects. So this
So I have question here.
Okay. I'm listening.
Yes, the energy of one quantum is hf. What is f? You've given out that h is Planck constant. What is f?
Okay, F, frequency.
Okay.
So in some textbook, you see it as that
Okay, there is another question there. Explain black body for us now.
the same thing.
Pardon?
Hello, can you hear me? Yeah, can you hear me?
Hello?
Can you hear me? Yeah, can you hear me now?
Yes, I can hear you now.
Okay, I said the F represents frequency. And in some textbook, you might see it instead of F, you see it as V. Some textbook, they'll write it as E, energy is equal to HV. But that V is also representing frequency because some textbook, they represent frequency with the letter, one kind of coily V. The V, they stylishly write the V. So the energy of sorry, how would I even call it? The energy of one quantum energy can be measured by multiplying the frequency of that energy by Planck's constant. So that's actually what Planck's theory was able to bring out, that we could measure the energy, measure the quantity of energy in a packet of energy. I don't know. It's kind of okay. I don't know why I'm always forgetting that I have an illustrator. So
What of the black body radiation?
okay, black body radiation is actually an experiment that was actually in physics though. But this experiment was talking about that there's an entity that we can call a black body, and this black body has. Can you hear me?
Not
No,
quite.
you said energy that I did not get that statement.
Okay. This black body is an entity. They assume it to be an entity that a material that exists that has the highest ability to absorb energy.
I can't hear you. I can't hear you,
Can you
please.
hear me? Now?
The line is breaking.
Can you hear me now?
Okay, it's clear now.
Okay, can you hear me now?
Yes, we can hear you, sir.
Yes.
We can hear you
Yes,
perfectly.
I can
Thank
hear
you.
you. Clearer now.
Okay. So what I was saying, I said this black body is an entity that they assume to exist that has the strongest ability to absorb any form of energy and the strongest ability to emit any form of energy. So a black body, they said it is a body that has an emissivity of 1. That is, it has the ability to emit radiation.
So
It
I
has the highest
didn't
ability
get
to emit
you.
radiation. And it has the high also.
So that black body, we are
Let
not
me,
getting
I don't
it.
know. Can you,
I didn't get it right though.
okay.
The thing is,
But everybody can hear me now.
yeah,
Yes.
Yes.
Okay. So black body to absorb energy, usually light energy, that has the ability to absorb light energy completely and also emits light energy completely. Did you get that?
yes,
Yes, sir.
Okay, so they said that it has an emissivity of 1. That is a constant that they use to measure the level of absorption or the level of emission of material. Say it has an emissivity of 1, that it has the highest ability to emit. So I guess that's the phenomenon that makes people say if you wear black clothes under hot sun, heat will be catching you because the black clothes has the ability to absorb this energy, heat energy. So it will absorb this heat energy and store it inside itself completely. So that is the reason why they always say don't wear black clothes under sun or when the weather is hot because heat will be catching you. It's not actually a cliche statement. It's something that can be proven through physics. So that's what the whole phenomenon of black body radiation is talking about. And also there is the reverse side of the black body. They say when it is trying to emit, it emits all the energy completely. If it's trying to give off energy, to give it off completely.
off completely. And when it's absorbing, it
Yes,
absorbs.
completely.
Said
I don't know my
something
slide. Can you get
concerning the value. The value.
the value? Okay, it has an emissivity of 1.
What? Negativity. Emitivity or
Emissivity,
Emissivity.
emissivity, emissivity. Emissivity. I'm sorry, I left my screen. I don't want. I want to know whether. Okay, you guys can see my screen, right?
Yeah,
emissivity of what?
of 1.
Emissivity of 1. Let me see. I'm looking for where I kept this
The last
slide.
slide though. Please bring out the last slide. I didn't
I know.
screenshot it.
I'm coming. Sorry, I'm coming. So this is where we are at black body here, Planck's quantum theory. So are we seeing it now?
Yes, sir.
Yes, sir.
Okay, so now let's go to the next. Let's go to the next one. Okay, photoelectric effects by one of my favorite scientists, Albert Einstein. So
Hello,
what's this
hello, sir.
yeah?
The last slide
Yeah, I
did
can
not
hear you.
explain.
That's this one. That's the Planck's quantum theory that I talked about.
Is it the continuation of the slide?
Yeah, this is that one I was talking about. We talked about
Not this
Chadwick.
one. Not this one.
Then we went.
Next one.
Then we went to.
Not this
We
one.
went to
We are
this
going
one.
backwards. Forward.
No, I'm going forward.
Go
This is
forward
forward.
again.
I'm going forward.
Uh-huh.
We've not gotten
Forward.
to this.
Uh-huh.
We've not gotten to
This
this
one.
point here. We've not gotten to
This
this
one.
point. Is this one before? We'll get to photoelectric effects before we get to quantization of energy.
This one now. Photoelectric effect.
I will treat photoelectric effects before I go to quantization of energy. So I want to teach photoelectric effects now by Einstein.
Explain that one now.
Yeah, that was what I was trying to teach now. So
Okay.
photoelectric effects by Albert Einstein. So Einstein showed that light comes in particles. So this experiment by Planck was proven to be true by Albert Einstein. As I said, one of my favorite
Now,
scientists.
please. As you're explaining, I want to be seeing the
Now
slide
you are
now.
showing the slide of quantization of energy instead of photoelectric.
Can you see it
Yes, sir.
now?
Yes,
Yes,
yes.
you
You are
can
seeing?
see it now.
Yes, sir.
Okay. Sorry. So this Einstein, he showed that light comes in particles. What this guy was talking about, that why light does not come in just waves. Let me use my illustrator to probably explain it now. So according to Einstein, he said that light, before they were assuming that light existed like this, that energy moves in waves. Energy moves in waves. So, but now, this guy, Planck, he gave the proposition that that energy does not actually move in just wave, that energy behaves both as waves and as particles. So then Einstein was able to prove it, that this is how these are energy existence. It moves in packets, that is broken particles, continuously moving, where each of these particles have a unique energy. Each of these particles have a unique energy. I don't know whether I'm communicating anything. So he proved this thing through what they call photoelectric effect. And this photoelectric effect experiment was, he carried what they call it. They carried a a metallic material, and they bombarded it with light wave, like even light from the sun. So this was the theory that actually led to even the discovery of solar panels. These solar panels that people use this day, because they found out that when light touch metal materials to an extent, there's a level of energy that would hit this metallic material, that once it reaches that energy, electrons will start leaving the surface of that material. Electrons will start coming out of the surface of that material. And this energy that these light particles must have is equal to the energy of electrons. So he said that he now gave this formula. He extended this guy's formula, this former formula from Planck's. He said that formula is not just E being equal to HF. He said that it's E equal to HF minus a constant, minus a symbol called phi, PHI, phi. A symbol called phi. That is this thing that looks like one coily P or coily W or coily U. I don't know what people are saying it as, but I'm saying it as a coily P. So he said that there is a constant that once this constant is an energy value, that once light is hitting a metallic surface, the metallic surface will be absorbing the energy until it gets until the light energy that is coming. Okay, this is how he said. He said that when light is being shone on a metallic material, the metallic material will keep on absorbing energy, and to get to a point where the energy that it is absorbing, the electrons inside that metallic material would absorb enough energy, and once they've gotten enough energy, enough, they would start jumping off the surface of this metallic material. And this kind of thing that where light causes electricity,
You
because
are
when electrons
tweeters,
start moving.
too. You are jotting something.
Oh,
You are tweeters.
I'm very sorry.
You're enjoying this lecture. So take it easy a bit.
Sorry, okay, I've heard you. Let me take it easy. So how it happens is this. This photoelectric effect.
Explain how when the light fall on the metallic material, the
Yes.
metallic material will continue to absorb energy, I think.
Yes, it will absorb energy. Then as it keeps on absorbing this energy, it will get to a point where it will absorb a particular minimum amount of energy. When that energy has been absorbed, the energy will be distributed to the electrons in that metallic material. And once these electrons, it's like as if they've eaten and they've belly full, they will start jumping. They will start jumping off the material, the metallic material. So let me use image to possibly illustrate what I mean. So this is the metallic material. Light is shining. Light wave is being incidented on it. Then electrons that are at the surface of, let me use another color probably to so you get perspective. So electrons that are at the surface will be absorbing this energy that this light is bringing. Once they are absorbing this energy, once they've absorbed enough energy and they've reaching an energy that is equal to this phi, That is like as if they've reaching they've gotten belly full, they've gotten satisfied with enough energy, they've gotten enough energy. And this energy, the minimum energy is just 5. Once they've gotten energy that is equal to 5, any extra energy they take in, they will start jumping out of this material, this metallic material. The electrons will start jumping out one by one. So this is the phenomenon they call photoelectric effect, where light would cause electrons to start moving. So when electrons start moving, electricity always happens because electricity is caused by the movement of electron. So that's why they call it photoelectric effect, where light represents photo, where light causes the movement or the flow of electricity. And how this thing happens is light comes down. And normally, if it were to be just really wave, according to Albert Einstein, if it was just be waves, it does not really make sense. Why? Albert Einstein says like this, that if it was true that light is just wave, why is that at the beginning when light just shine on the material, electrons don't just start jumping out? The reason why they wait for some time before they start jumping out is because they keep on absorbing an energy continuously, small, and the light is bringing those energy. The light doesn't just give the energy just once. It gives it in bit by bit by bit by bit by bit. So this bit by bit is what he called photons. That is small particles of light. He called them photons. And these photons, he said that they have a specific amount of energy, which is equal throughout all the particles. So now when these particles, these small photons are being absorbed by electrons on this material, this metallic material, they keep on absorbing. They will reach a point where their energy, they've gotten enough energy. And once they've gotten enough energy, any extra photon that they eat again, they will jump out of their surface, the metal surface. And because they jump out, it means that electricity has started flowing. So this was the idea that they found out. When they found out this thing, that was when they started using what they call it. That's how they started developing solar panels. Because these solar panels, they use materials that are not just metal. They use materials that perform better than metals in this photoelectric effect. So what happens is that this light will also come from the sun, hit the surface of this plate of our solar panel. So the particles, the electrons in these panels will be absorbing this light. Then when they get enough energy, they will start jumping off. But there is now a system that now draws away this electron into a wire. So now, this electron, instead of them to jump out directly, for a solar panel, there is something that would now pull these electrons out through a wire. So this electron now will not just go away into the air. They will now start flowing into the wire. And as they start flowing into the wire, current will start flowing. So as these electrons are attracted into the wire, current would then start flowing. That's how solar panels work. I don't know whether it's clear. Okay, let me try to re-explain it. So let me use human being example now. It's just like as if they said everybody inside a particular room has everybody has a number. Everybody has number. Then there's someone outside. Okay, no, everybody is hungry. Everybody inside a particular room is hungry. Then there are small children, there are adults, there are small children. So everybody, assuming that everybody is very weak. So then now they started bringing food, one loaf of bread. I'm giving everybody one. So once someone eats the amount of bread and makes him full, they say if you are satisfied, you can stand up and leave. So that's what's happening in this photoelectric effect. Bread is coming in form of light, one by one. So these electrons will be eaten. Once anybody, maybe one of the electrons, his own satisfaction point is when he eats 3 loaves of bread. So once he eats 3 loaves of bread, he's satisfied. If you give him any other bread, he'll say, no, I don't want, and he will leave. So that's what's happening. Electrons then, they have their own loaf of bread that they keep on eating, which is in form of light energy that they call photons. So they will be eating this energy one by one by one by one. So, but when any of them has gotten satisfied and you give it an extra, that extra, instead of it to hold that extra, it will use that extra and escape from the surface of that environment. So that's what happens in photoelectric effects. So now Einstein now said that it's not just that lights will just shine on the metallic material and they will start jumping up. There is a minimum amount that each of these electrons would absorb before they will start jumping off. And that minimum amount is what they call that phi. That thing that looks like W in this formula. E equals to HF minus W. So that's they call it work function.
Okay, that's PHI.
Yes,
Is
PHI.
that
That's this thing here.
all
Yes,
right?
this thing here. Let me.
Is that in, sir, is that in pi or omega?
It's not
This,
pi. This one is, I don't say pi. I don't say pi. It's PHI. Phi is a Greek letter. PHI. Omega looks like this. Omega looks like ohms. This one looks like this, something like this.
Okay, I've seen it now.
so what do you say that phi is?
It is known as work function. This thing that we have here, work function. So
Okay,
it is the satisfaction point of each of the electron, the minimum energy that each of the electron needs to eat, and they will be belly full.
okay,
Yes. So once they've absorbed, they've absorbed that minimum energy, they can now start jumping off. So once you see something that is emitting any energy out, it means it has already overcome this minimum energy. Once you see any material that is emitting energy out or emitting electron, it means that the material has absorbed this is number of bread and now is giving off the excess now in form of electron. I don't know whether it's clear.
yes, and it's clear. Connect it to solar panel because you said that for solar panel, as they are jumping out, they'll be connected into a wire.
Yes. So this let me use this. Let me just draw a diagram. Probably illustrate it better. So this is like, let's assume that this is our solar panel. Sun will be coming to this solar panel. Sun rays will be coming to this solar panel. Then when this photoelectric effect, when this thing happens, the electrons would want to start jumping out of this metal. We want to start jumping out. But now in the solar panel, there is a system that they connect that would now make, instead of these electrons to jump out, somebody will catch them and send them into a wire. So this electron, instead of them to jump out directly, this electron they will then be sent into this wire. Instead of them to start jumping out directly, they will then be drawn into the wire. And as they start moving into the wire, as the electrons start moving, that's how we start seeing currents. So that's how the phenomenon of this solar panel happens. I don't know whether it's clear.
Yes.
sir.
Yeah, so that's the phenomenon that led to the discovery of solar panels. They found out that, okay, when light hits a material to an extent, this material will start releasing electrons. So instead of these electrons just be jumping up and be wasting, we can divert these electrons into a wire. And once these electrons go through the wire, we've already allowed light, current to start flowing. So then that's what they did. They now found a mechanism to direct the electrons that are jumping off of the surface of the material into the wire and
For the
led
generation
to the
of
flow of current.
electricity.
Yes, thank you. So that's for this photoelectric effects. So in order for us not to not to waste time. So quantization of energy now is just a summary of what these two guys, what Planck and Einstein talked about. So quantization of energy is just trying to talk about that truly is a confirmation that truly energy don't just exist. This quantization of
Bring out
energy is
the
just
slide now. Bring out the
you said?
slide, sir. The slide.
Okay, can you see it now?
Yeah.
Okay.
Yes, sir.
So now this quantization of energy is trying to talk about the conclusion that truly when light does not just exist as just waves, they exist as both waves and particles. And these particles now, they have individual, they are small bits, and these small bits can be measured. These small bits can be measured and they have a specific energy. So that's what this whole thing is talking about. So, and this idea now led to different experiments and different discoveries. This was the experiment that was, I guess, this idea was what actually led to spectroscopy in later levels of chemistry. If you're someone that is probably studying chemistry, you get to a point where you study spectroscopy, where they were talking about different energy levels, infrared energy level, ultraviolet. Those ones are for people that are going to be going into chemistry fully. So this idea was what actually the discovery of this truth that light does not just exist as wave, it exists as both particle and can be measured as units called quanta. This thing is what led to discovery of different other things like spectroscopy, UV, X-ray, and all those many light-related stuff and other things that are involving waves. So this thing is arise as a result of being able to measure energy, which is called quantizing energy. That's quantity from the word quantity. They're trying to quantify energy, something like that. So they're saying that energy is not just a wave that just flows. It can be measured as individual packets called quanta, Quanta, quanta. So that's all for today's class. That's all for today's
You said
class.
that it
And
can be measured as what, sir?
quanta, Quanta,
No,
quanta.
there's something you said before that quanta.
Okay, I
Individual
said
packets.
Hmm?
okay, individual packets. Individual packets that light
Uh-huh.
can be measured. Yes, individual packets.
Individual
Thank
what?
you.
Packets.
Packets, like
Okay.
matches packets, packets.
Okay.
Uh-huh. So that's actually the end of today's class. So today's class, we are able to talk about the Dalton's atomic theory, how it started, and how Dalton was feeling on top of the world. He gave his theory, he gave
That he
four at the same
discovered the
time.
first theory.
Yes. So then he gave his own theory, but later, people started finding out that this theory sometimes it holds true, while some other times it does not hold true. Right. I gave us the different points where it hold true and when it did not hold true, and the different conditions. Then we also went into Thomson's discovery of electron. We went into Rutherford's discovery of the nucleus. We went into Chadwick's discovery of the neutron. Then we also went
Neutron.
into Planck's energy quantization. So, and also Einstein's photoelectric effect. So this is actually the end of today's class. I don't know if anybody has any other question that probably I could clarify them on.
Sir, give us questions now.
Okay.
That is
That's interesting.
how do I put it? At least questions that we will expect from the
Okay. Kind of question I
lecture.
used to expect.
Yes, the kind of
Okay.
question that they will ask us.
Under this Dalton's atomic theory, you should know all the four types of Dalton, all the four theories of Dalton, because how questions come out under this Dalton's atomic theory, they would list maybe like three of his theory and say which one of them. They will now list a fourth one that is not among that maybe might sound familiar, or they will even tweak the word. They will say, okay, they can even tell you atoms can be created, but atoms can not be destroyed, but they can be created. Atoms can neither be created or can be destroyed. All atoms are, they will just scatter it like that to see whether you really know what these atomic theories are, these Dalton's atomic theories are. That's one way that the question can come out. They will try to tweak your mind to see whether you know its theories offhand. Another way it can come out is that they will tell you the modifications that happened to Dalton's atomic theory. What happened? What made them cancel the theory? Or what was the modification that was done to the theory that says that atoms can neither be created nor destroyed? What led to the cancelling of that theory? And what actually led to it was when they found out that in nuclear reactions, energies, atoms can be destroyed, and also in nuclear reactions, atoms can be created. So,
Can be created.
yes, so all these things, all these things I said at the beginning are the ways you can see questions under then for for J.J. Thomson's electrons theory, they will tell you, okay, what is the name of the experiment that led to the discovery of maybe electrons? So the name of the experiment is the cathode ray tube electrode. The cathode ray experiment. Yeah, cathode ray experiment. Cathode ray experiment. And who is the person that discovered it? J.J. Thomson.
J.J. Thomson.
J.J. Thomson is one that discovered it. Yes. So J.J. Thomson was one that discovered it. So, and also they said there was also a model that was before. There was also a model that was before Rutherford's own discovery of the atomic structure. Rutherford was the one that discovered the real atomic structure. And he said that they can ask you that which of these particles are found in the nucleus. Then they will start listing different particles or different things. So it's best for you to know that in the center of the nucleus, we have only two particles in the center of the atom, that is in the nucleus. Two particles are only present in the center of the atom, and the two particles are protons and neutrons. So those are the two particles that are present. So then also they can tell you which of these particles is not found in the nucleus. They will tell you electron, this thing. So it's just for you to be able to know these things for what they are. If you can be able to know them for what they are, no matter how they want to bend the question, you'll be able to answer it correctly without shaking, because you already understand what it is. It's just to calm down, read the question, and understand what they're asking you for. Then you find the answer in the answer will just be there looking at you. So then for the Chadwick's neutron, there is barely question that comes out. There's barely question that comes out from that one.
There will be straight.
So it does that they will just ask you which thing proved that it was that Millikan experiment. They'll tell you what is it about, what was it trying to find out, what was the Chadwick experiment trying to find out, all those kind of stuffs. Those are the things that always come out from those parts. Then for this Planck's experiment, they could tell you what is the energy of a photon or of a particle of energy with frequency of, they will give you the frequency and they will tell you to find the energy. It's just for you to use the Planck's constant and times the frequency, you get the energy. Or they will tell you, yeah, they could also tell you there's a particular particle that has an energy of this. What is the frequency? So it's just for you to turn this thing, make the frequency subject to formula, divide the energy by the Planck's constant. So that's how the questions come out. Then from Einstein's own photoelectric effect, they can ask who discovered photoelectric effects? Einstein, Albert Einstein. And what is they can try to ask you question about how photoelectric effect occurs. You know that it happens as a result of light touching a particle. And once the thing gets an amount of energy, the electrons start leaving the surface of this particle, leading to the flow of electricity. So that's just the whole thing.
Hello, sir.
You said?
You did tell us who discovered the photoelectric, the one you said now.
Yes,
Is
Albert,
it
He said
yes,
it now.
Albert Einstein. Albert Einstein.
All right.
So that's all for today's class. Thank you all for attending, and thank you all for being attentive.
You've done noble.
So, yeah, thank you so much, man.
Good night, everyone.
Good night.
Bye.
Good night.
Bye.
Bye.